Good morning, students. Today we discuss about the bitwise operators. Okay. First, we have to introduce what is the bitwise operators. Okay. Basically, bitwise operators are used to manipulate the individual bits within an operand. Okay. Uh, Basically, that means we can say that bitwise operators are that operator that works on the bits. Okay, there are different types of bitwise operators here: bitwise not, bitwise and, bitwise or, and bitwise exclusive or. Basically, these operators works on the logic gates, electronic logic gates, that is like and, or, exclusive or, and not. Okay. So basically, we discuss about one by one bitwise. What do you mean by bitwise not? What is functionality? What is the bitwise and what is functionality? Okay. In There are four. Basically, there are six operators. Okay, that are in the category of the bitwise operator. Okay, the fifth and sixth is the left shift and right shift operator. Okay, but I only include these four. In the next session, we discuss about the left shift and right shift operator. Okay, so basically here we discuss about the bitwise not, bitwise and, bitwise or, and bitwise exclusive or. Basically, bitwise not is what? It reverts the bits of the operand so that one indicates, that means the true, and zero indicates false. As we know that each variable can be represented in a binary form. Suppose let us an example a, that means a equal to 5, and we can write it in a binary form 101. So when we use bitwise not operator, then 101 will be converted 1 into 0 and 0 into 1. That means it becomes 010. Okay. Basically, this is the working of the bitwise not operator. Okay. Basically, it is represented by a single tilde sign, and it is just like a unary operator and requires only one operand. It is also known as one's complements operator. Okay. It results 1 if bit is 0 and 0 if bit is 1. Okay. Same as not gate in the electronics. Okay. Next is the AND gate. Okay. This is what it is represented by a single ampersand sign, and it results 1 if both the bits have the values 1, otherwise it would result 0. It works same as the AND gate in electronics. Okay. Next, in bitwise or, it is represented by a single vertical bar. Okay, it results 1 of both the bits or either of the bits have the value 1, otherwise it would result 0. It is similar to the OR gate in the digital electronics. Okay. In the last bitwise exclusive or, it is represented by a single caret sign. Okay, single caret sign. Generally it is also used just like a power in the different programming language. Okay, it results 1 if one and only one bit between the bits have the value 1, otherwise it would result 0. It works as the same as the exclusive OR gate in the digital electronics. Okay, basically this is the theoretical concept. Now we go for the practicals. Okay, that means here in that we can use the variables and use the bitwise operators like not, and, or exclusive or. Okay, now we go for the practical session. Okay, now can write cmd. Okay, edit. First of all, we have to use bitwise operators. Okay, bitwise operators. Okay, what is the bitwise operators? It is the operator that works on the beats. Okay, that works on the beats. Okay, so basically the working the working of bitwise operator totally based upon the the different gates in digital electronics. Okay, now we discuss there are different types. First we discuss bitwise bitwise and okay, this is basically it is as an ampersand. Okay, ampersand, this is also in C and C++, it is also known as the reference operator. Okay, clear? Now we discuss what is the use of the bitwise and operator. Okay, first we write basically it results one. Okay, one, that means the one if both of the bits have the value 1. Okay, that means ki in both of the bits having the value 1, that means ki it the output of that value will be 1. Okay, otherwise it would result 0. Okay, for example, suppose the value of example suppose the value of a equal to 5 and the value of b equal to 6. Okay, now a equal to, that means in binary format we write 1 0 and 1. Okay, and b, that is the 6, we can write 1 1 and 0. Clear? So basically this is the concept. And now when we have to use a and b, okay, then what will be the output from this? 1 and 0, the first bit is 1, second bit is 0, so the output will be 0. Okay, the first bit is the 0 and second bit is the 1, then that means the output will be 0. Okay, in the same, first bit is 1 and second bit is 1, that means the output will be 1. Okay, so here we can see that basically this is the result of the a and b. Again we see it results 1 if both of the bits have the value 1. Okay, both of the bits having the value 1, the output will be 1, otherwise it would result 0. Okay, so basically the value will be what? The value will be a and b is the 100. Again we convert it a binary to decimal format and the output will be 4. Okay, this is the use of the bitwise AND operator. Clear? Now we can use bitwise OR. Okay, bitwise OR. Basically it is represented by a single vertical bar. Okay, it is represented as a single vertical bar. Okay, what will be the functionality? It results 1 if both of the bits or either of the bits have 1, otherwise it would result 0. Clear? It works on the same as the OR gate in the digital. For example, let us consider also an example. Okay, suppose here we example. Suppose again we use the value of a equal to 5. Okay, 5, and the value of b equal to 6. Okay, now we have to convert these two values in the Boolean form, that is 1 0 1, and second is the b, that is 1 1 and 0. Okay, now we have to find the value of a or and b. Okay, a or b. Now what will be the output from here? 1 0, either of the bit will be have the value 1. Either of the bit, that means first is 1 and second is 0, the output will be 1. Second, either of the bit equal to 1, that means the output will be 1, and both of the bits will be 1, that the output will be 1. Okay, so what will be the output? For the output we have to convert the results that is available in binary, that means bits, convert into the decimal. So what will be the output? 4, 2 and 1, and is 7. Okay, so that means the output of a or b equal to 7. Clear? Now we discuss about the bitwise XOR, that is also known as the exclusive OR, and it is basically indicated by the single caret sign. Okay, single caret sign. Okay, now how it works? Okay, basically first of all I want to say it is the binary operator. Okay, it is the binary operator. Basically, as we know that there are two types of operator. One is the binary operator and second is the unary operator. Unary operator, how can we differentiate between unary operator and binary operator? The operator that requires minimum one operand. Okay, that is known as the unary operator, like increment operator, decrement operator, exclusive not bitwise not operator. Okay, so these are the basically are in the category of the unary operator. But when we discuss about the binary operator, that means it requires minimum two operands. Okay, to perform their task. Okay, so basically bitwise exclusive OR is also a binary operator, but bitwise, when we discuss about the bitwise not, it will be a unary operator. Okay, now we discuss about the bitwise exclusive OR. It results 1 if only it results 1 if 1 and only one bit between the bit value 1. Okay, bit value 1, otherwise the bits have the value 1. Okay, otherwise it would result 0. Okay, now we see that means it results 1 if one and only one bit between the bit value 1, otherwise the bits have the value of 1 otherwise. Basically to understand this, let us see an example. Okay, again we see, suppose a equal to 5. Okay, equal to 5 and b equal to 6. Again we have to use to convert a into the bits, that is 1 0 and 1. Second b equal to 1, 1 and 0. Okay. Now we use the exclusive OR. So exclusive OR is the A. Exclusive OR we use the caret sign, that is b equal to. Okay. What will be the value? A caret b. Okay. Now either of the value will be 1. Both of the bits should not be 1. Okay. That means ki either means 1 in the A, first bit is 1 and second bit is 0. Basically, here we can see that it results 1 if one and only one bit between the bit value will be 1. That means ki, both of the bits having single one bit, the output will be 1. So basically, it will be 1. First bit is 0, second bit is 1. That means either of the bit is 1. That means the output will be 1. Here both of the bits be 1. That means the output becomes 0. Okay. Now in this situation, the output of after after the performing exclusive OR between the variable a and b, we find the output and 3. Okay. So basically, this is the conversion of A exclusive OR B, and where the value of A equal to 5 and the value of B equal to 6, and here we get the value 3. Okay. Now we have to see bitwise not operator. Okay. Bitwise not. Okay. This is also known as complement. Okay. Basically, this complement operator, bitwise not complement operator, it is generally indicated by the tilde sign. Okay. First of all, it is a unary operator. Okay, and requires only one operand. Okay, only one operand. Okay, it is also known as one's complement. Already you see study in the digital electronics or computer architecture. One's complement operator. Okay, it results 1, that means 1 if bit is 0. Okay, and 0 if bit is 1. That means it works, that means it converts if the bit convert 1 into 0 and 0 into 1. Okay, it is the same as the NOT gate in the digital electronics. Okay, now we can see example is that suppose a equal to 5. Okay, now when we convert this in the binary format, that is 1. Okay, now we can use complement A. It will convert 0 to 1 and 1 to 0. So 1 will be converted into 0, 0 will be converted into 1, and 1 will be converted into 1. Okay, so the result will be, what will be the result? Minus 6. Okay, so here we discuss about the different types of operators, and it's also working process. Okay, so here we discuss about the bitwise not, bitwise and, bitwise or, and exclusive or. Okay, now we go for the practicals. Okay, save, that is bit1 dot class bitwise. Okay, Now we have to write main method public static void main string as. Okay. Now we have to discuss. Now we use two values 5 and b equal to 6. Okay. Basically, these two values has been also used in the previous session. Okay. Now we use such operators like bitwise and bitwise or bitwise not. Okay. System dot out dot println. Okay. And results. First of all, we see A and B. Okay. Now we see what will be the result. I'll save it. Now bitwise dot java. Okay. Java C compile file name with extension java. Applied to a java string. Okay. Here we see edit what is the bitwise dot java. Okay. Suppose here we write C. Okay. And here we can write int C equal to A and B. Okay. Now we see file save. I like it. Java C. Okay. Now here we have to bitwise. Okay. The value is the 4. Okay. Now we see the next, that is the OR. System dot out dot println. Okay. Exclusive OR result equal to as suppose D. Okay. Now we write in D equal to A and vertical bar D. Okay. Now here we can see the result. File save. Now file exit. Okay. Java C compile. A string literal D. Okay. See. Oh, basically, here we can see what is the error. Basically, OR will be written in between the double quotes. Okay. Here we write only a single quote, and here we do not mention the. Okay. This is the error. This is known as the syntax error. Okay. I'll save file. Exit. Okay. CLS. Java C. Bitwise. Java. Okay. Now a Java. Bitwise. Okay. The OR gives 7. Okay. So basically, this is the output of the bitwise OR operator. Okay. Now we see the exclusive OR output. So basically, in output of this is the 4, and output of this is the 7. Actually, this output will be matched with the previous session that has been where we can see the different types of examples of and OR and exclusive OR, where we also take the value A equal to 5 and B equal to 6. Okay. Now system dot out dot println. Now we check the exclusive OR. Okay. Exclusive OR equal to plus now E. For this we can write int P equal to what will be value A, exclusive or, that is the caret sign. Okay, now B. Now we can see what will be the value. File, save, and file, exit. Okay, Java C bitwise. Okay, exclusive or equal to 3. Now we can see bitwise not. Okay, this will be the 3. Now we see the complement operator. Okay, now system dot out dot println file sign, that is a complement operator. Okay, we can write complement equal to plus. Now suppose we take a variable f. Okay, and here we can write int f equal to suppose 5. We have to find the 5. In this negation of a, if we find the ones complement of 5, okay, the output will be -6. Okay, here we can see also by the program file exit our C. Okay, now -6. Okay, so basically here we can I hope you understand all the bitwise operators and what are the different mechanism that is adopted by such type of variables. Okay, the output of the AND is the 4, 7, 3 and -6. Okay, now exit. Basically in this session we discuss about the what are the bitwise operators. Okay, and basically the main concept behind that, what are the mechanism that has been followed by such type of operators. Okay, basically bitwise not is also known as the complement operator, and it works on the basis of one's complement that we already studied in the computer aggregation or digital electronics. Okay, basically bitwise and or bitwise or an exclusive or that also works on the basically different gates in the digital electronics. Okay, now we conclude the session, and in the next session we discuss about the different shift operators, right shift and left shift. Okay, thank you.